A fuse, after all, is a resistor with very low ohmic value, but it's a resistor that supports a maximum power, or in other words, an amperage indicated by the manufacturer. As you've seen, we start with 5 amp fuse. We're going to try to gradually circulate current. There's a voltage drop. Then, at the end of the video, I'll explain something very curious that happened to me with a voltage drop. We see here that the power developed is 0.7 watts when it's close to 5 amps. The fuse is hot but doesn't blow. We're going to continue increasing the power by more than what the voltage drop across the fuse is half a volt. Now, the filament finally glows and blows. A fuse that the manufacturer says is 5 amps held up to 9.2 amps. We're going to try another 5 amp fuse to see if the other one was faulty. We reached 5 amps, went from 5 amps, 6 amps, 7 amps, and it blew at 9.3 amps, and the current drop was half a volt. I want to do a test with a 1.5 volt section cable. What the regulations say about this cable is that the safety current is 16 amps. What I'm going to do is count the copper hairs it has. There are 31, and then multiply the result. I'll remove them all, leaving only one hair. That hair will act as a fuse because I'll eventually melt it to see how much it melts. But let's look at the temperature. As soon as there's a minimum temperature, that means that cable is already exceeding a safety amperage. The ambient temperature is 21 degrees, and we start to increase the current. We reach 0.9 amps, and it's risen 1 degree. We can round up to 1 amp. With 1 amp, the cable is already emitting significant heat. Therefore, 1 amp multiplied by 31 hairs equals 31 amps. In other words, the cable would already be exceeding the maximum safe current at 31 amps. So it's logical that 16 amps is the maximum safe current. However, be careful because I'm doing this with direct current. With alternating current, it would generate much more resistance and more heat. Let's increase the current. At 5 amps, the filament is at 70 degrees Celsius. At 10 amps, it melts. Well, that means multiplied by the wires, it would be about 300 amps. At 300 amps, the cable would be instantly depleted. But of course, since this cable is normally for alternating current, it would be much lower. And now for the test I mentioned at the beginning of the video that I wanted to do with a fuse I installed for a device that operated at very low voltage. The fuse is 500 milliamps or 0.5 amps. I set it to 1 amp. Note that the drop is 3.8 or 3.9 volts. That's a very significant drop for the electronic device I was using. Let's try this car fuse to see if it's the same as the other 5 amp fuses. We've seen that we're more than capable of handling 5 amps, just like before. It even handles 10 amps and it doesn't even glow. Well, the plastic has melted, but it doesn't blow. This must be for quick short circuits, where a lot of current flows through suddenly, protecting conductors and nothing else. Now I'll try the 10 amp fuse, which I won't even get anywhere with. I hope you enjoyed this test. See you next time.